Determine two ways to restrict the domain of x minus 1 plus 3 so that its inverse is a function. This isn't a crazy concept, but this is one that people make lots of mistakes on. So we're going to really try to explain it fully. First of all, currently, y equals x minus 1 squared plus 3. Currently, it does not pass the horizontal line test. Can you see that? Right? If I draw a horizontal line, I hit the graph twice. Obviously, a parabola doesn't pass the horizontal line test. The good thing about these restricting domain questions is, so far, and it could change, but so far I've only seen it on the exam with parabolas. But they could possibly ask it with something else. It's not super hard, but generally it's with parabolas. When we restrict the domain, we add a restriction saying we're only allowing certain values of x. So an example of restricting the domain would be, say, I only want to take positive numbers. You often have to do that in a real life example, right? How much time does it take to get to this point? Well, you never say, oh, it's going to take me about -7 minutes. I could get to that point in the past. Right? No. Right? We restrict the domain. It only makes sense to talk about positive numbers. So if we only talked about positive numbers, x is bigger than 0, that would erase this part of the graph. Unfortunately, just erasing that part of the graph, does it pass the horizontal line test? No. Okay. With a parabola, does it make sense that if you find the vertex, this point right there, and erase half of the parabola from the vertex, I went all the way up to there, now it passes the horizontal line test. So, to pass that horizontal line test, we have to think of only half of the parabola. And it says we have to come up with two ways to do this. Can you see that you could we've kept the right half, we could also keep the left half. So what I'm going to do is I am going to color code the right half in blue, and I'm going to color code the left half in green. In blue, what's our domain restriction? Which x values are we using for our blue graph? In other words, what is the domain of the blue part? The domain restriction would be that the x has to be bigger than or equal to 1. And in the green, second one, the domain would have to be less than or equal to 1. So a domain restriction question is asking about this original graph. How could we do that so it passes the horizontal line test? And we could do that by finding where the vertex is. And really, on the vertex, we're only really worried about what that x value is. We don't care what the y value is, because we want to restrict the x values. So my x value of that vertex is at 1. So in this case, the blue part is x is bigger than 1. The green part is x is less than 1. If I move that parabola around, that's going to change my x value. It will change your domain restriction. Okay? That's big idea number 1 for this question. This question has a couple big ideas. Big idea number 2, it says write the equation of the inverse each time. And use a graph to illustrate. I actually think the graph part is easier to start with. Okay? Again, we're going to color code. First of all, if my vertex is at 1, 3, if I switch x and y, I'm going to still put it in red. Would you agree your vertex would be at 3, 1? Then, on my blue graph, let's find a couple points. I have a point here, and I have a point there. If I have a point at 2, 4, I need a point at 4, 2. And if I have a point at 3, 7, I need a point at 7, 3. Does that make sense for your blue graph? Perfect. Similarly, we'll do the green graph, and you would get 4, 0, and 7, -1, and get the green graph. And we need to write the equation of the blue graph for the inverse of the blue one. And we need to write the equation of the green graph for the inverse of the green one. So I'm going to leave a little bit of space underneath each of these. And I'm going to remind you that you can find the inverse algebraically by switching x and y and solving for y. So if I did that, I get x equals y minus 1 squared plus 3. And if you want to solve for y, first, let's get the squared by itself. I have to subtract 3 on both sides. Then I can get rid of a square. By square rooting. And don't forget the plus or minus. And finally, we can get y by itself. By adding 1 to both sides. This actually creates 2 equations. One with the plus, and one with the minus. And what we have to determine is one of those equations will be the blue one, and one will be the green one. I'm going to just zoom out here so we can see everything. Now, a couple of things you can do to figure this out. Okay, I'm going to tell you that I know this is the blue one, and this is the green one. How did I figure that out? Theo, what do you see?
number 2 goes into the negative, number 1 doesn't.
This one has some negative values because it's going down, right? And a square root, when you have a square root, it's always a positive answer. So that's a good way of looking at this. When you square root something, it's always a positive answer. So if the square root of something's always positive or 0, and you add 1, the blue one has to always be positive. The green one has a possibility of being negative since this square root is always positive times a negative. This is always negative. Then we add 1. Sometimes it's positive, sometimes it's negative. So that is a good way to figure out which one is which. Other ways. There's lots of ways on this one where you can see. What do you see? What's that? Check a point. Perfect. So if I plug in 7 into this one, I get 3. If I plug in 7 into this one, I get -1. So we can plug in a point to check. Perfect. Any other ways? I'll try to think of as many ways as I can too. So if you miss one, I'll think of another way. And what you have to come up with is what's going to help you the most. Anybody else have any other ways they see? Okay. Maybe another way you could use, do you know how to graph a square root? Yes. The blue one says take a regular square root, move it 3 to the right and 1 up. Is the blue graph or the green graph? A regular square root, move 3 to the right and 1 up. The blue graph. Can you see that the green graph is a regular square root with a vertical reflection? Where do you have a vertical reflection with a negative out in front? So we can see that as well. Okay? Now we've come up with 3 ways. Method number 4. If there's a domain restriction on the original, that will mean that there is a range restriction on our inverse. So the domain restriction that x has to be bigger than 1 means our range has to be bigger than 1. Only the blue one works. And this is sort of similar to your positives and negatives, just said in a little different way. It's important for us to try to understand all these different connections, because sometimes one of your ideas won't work, and you might have to come up with a secondary idea. So the more ways you can see how it's connected, the better. Okay. Circle questions 10 and 12.